For any assignment-related queries, call us at +1 678 648 4277. You can mail us at info@databasehomeworkhelp.com or reach us at https://www.databasehomeworkhelp.com. Database Assignment Help. 1. Write a query using the select statement that will compute times and IDs when any sensor's light reading was above 550. Show both the query and the first few lines of the result. Select result_time, not id from exp_table where light greater than 550. Databasehomeworkhelp.com. 2. Write a query that will compute the average light reading at sensor 1 between 6 p.m. and 9 p.m., inclusive of 6 o'clock p.m. and 9 p.m. Show the query and the result. A basic aggregate query. The : operator does typecasting in Postgres. Here we use it to convert result time, which includes a day and year, to a time type which is just the time of day. Select AVG, light, from exp_table where nodid equals 1 and result_time, time equals 6 p.m. and result_time, time equals 9 p.m. Average 165.76060606060606060663. Write a single query that computes the average temperature and light reading at every sensor between 6 p.m. and 9 p.m., but exclude any sensors whose maximum voltage was greater than 418 during that time period. Show both the query and the result. This query required a grouped aggregate. The halving clause allows us to select only aggregate records that meet a specific condition. Note that in this case, no sensor had a voltage greater than 418. If you run the query until 9:59 p.m., you would see that sensor 2 is excluded. Databasehomeworkhelp.com. Select nodid, AVG, light, from exp_table where result_time, time equals 6 p.m. and result_time, time equals 9 p.m. group by nodid having max voltage less than or equal to 418. 4. Write a query that computes the average calibrated temperature readings from sensor 2 during each hour, inclusive, between 6 p.m. and 9 p.m., i.e., your answer should consist of 4 rows of calibrated temperatures. A combination of a join between the exp table and the calibtemp table and an aggregate. Note the confusing wording of the question. I intended originally for the answer to consist of 4 rows representing 67 p.m., 78 p.m., 89 p.m., and 9:10 p.m., which is what I've shown here. Many of you provided an answer with just 3 rows, which was also fine. Select extract hour from result_time, AS hour, AVG, calib, AS temp from exp_table, calib_temp. Databasehomeworkhelp.com. Where raw equals temp and nodid equals 2 and extract hour from result_time, between 18 and 21 group by extract hour from result_time, order by extract hour from result_time. 5. Write a query that computes all the epochs during which the results from sensors 1 and 2 arrived more than 1 second apart. Show the query and the result. Note that you can use the difference, minus, operator on timestamps in Postgres, and that the string 1 second refers to a period of 1 second. The easiest way to answer this query is with a self-join, a join between 2 instances of exp table. The answer below includes both result time and epoch columns, so to verify that the answer is correct. Note that you had to find times where node 1's data preceded node 2's in cases where node 2's data preceded node 1's. Databasehomeworkhelp.com. Select e1.result_time, e2.result_time, e1.nodid, e2.nodid, e1.epoch, e2.epoch from exp_table AS E1, exp_table AS E2 where E1 dot result underscore time E2 dot result underscore time 1 seconds or E1 dot result underscore time E2 dot result underscore time 1 second, and E1 dot noded equals 1 and E2 dot noded equals 2 and E1 dot epoch equals E2 dot epoch. databasehomeworkhelp.com. 6. Write a query that determines epochs during which one or two of the sensors did not return results. Show your query and the first few results, sorted by epoch number. You may wish to use a nested query, that is, a select statement within the from clause of another select statement. This question didn't really require a nested query, it can be computed with a simple grouped aggregate. Select epoch from ext underscore table group by epoch having count, asterisk, 3 order by epoch. databasehomeworkhelp.com. 7. Write a query that produces a temperature reading for each of the 3 sensors during any epoch in which any sensor produced a reading. If a sensor is missing a value during a given epoch, your result should report the value of this sensor as the most recent previously reported value. If there is no such value, example the first value for a particular sensor is missing, you should return the special value null. You may wish to read about the case and outer join SQL statements. This query is substantially more complicated than the others. The easiest way to answer it is to decompose it into parts and then combine those parts together. First, we can build a subresult that contains a 1 entry for every sensor during every epoch when at least one sensor reported using an unrestricted join, in other words, a cross product. Select noded epoch from, select distinct epoch from ext underscore table, ASES, select distinct noded from ext underscore table, ASNS, ASE2. Then, we can combine this with the list of sensor readings, substituting nulls for any pair of nodeids and epochs in the cross product that doesn't also appear in the original list of readings. We use an outer join to do this. Select E2.noded, E2.epoch, from ext underscore table ASE1 full outer join. databasehomeworkhelp.com. Select noded epoch from, select distinct epoch from ext underscore table ASES, select distinct noded from ext underscore table, ASNS, ASE2 on, E2.noded equals E1.noded and E2.epoch equals E1.epoch, order by E2.epoch, E2.noded. Finally, we need to replace the nulls in this list with the most recent non-null entry for this result. We can use the case statement to replace a particular value with the results of a subquery. Alternatively, SQL provides the coalesce statement for the special case of replacing a null value with some other result. Putting it all together, we get: select E2.noded, E2.epoch, case when E1.temp is null, then select temp from ext underscore table where noded equals E2.noded and epoch equals, select max epoch from ext underscore table where epoch E2.epoch and noded equals E2.noded. databasehomeworkhelp.com. Else E1.temp end, from ext underscore table ASE1 full outer join, select noded epoch from, select distinct epoch from ext underscore table ASES, select distinct noded from ext underscore table ASNS, ASE2 on, E2.noded equals E1.noded and E2.epoch equals E1.epoch, order by E2.epoch, E2.noded. databasehomeworkhelp.com. 8. Write a query that determines epochs during which all 3 sensors did not return any results. Note that this is a deceptively hard query to write. You may need to make some assumptions about the frequency of missing epochs. The trick here was to realize that there's no built-in way to get SQL to build a list of all numbers between 1 and n. If there were, we could simply take the difference between databasehomeworkhelp.com. Such a list over the range min epoch to max epoch and the actual list of reported epochs. Instead, I assumed that there were no missing gaps of size greater than 4, and then build